Hello, my name is Aditya Nair, and I'm a 16-year-old Polygence student. I'm calling in from the East Coast of the United States, and this is my Polygence project. My mentor is Maria. She specializes with AI and machine learning. My project here is a conference talk, which it will be mixing in elements of machine learning and space together. It's more of a sort of review paper slash review research, and it's really focusing on the history of how machine learning has been used with studying neutron stars, specifically through gravitational waves. My main reasoning for choosing this project was mostly because it took two things I love about the STEM field and just sort of threw them together and combined them. I've always been fascinated by technology, whether it was in real life or in even sci-fi movies, of the idea of technology advancing and becoming more sentient and being able to help humanity in research or even the medical field or any other fields, and more specifically in space, whether it's space exploration or studying other space phenomena, which I was also fascinated by, as space in general has been something I've been satisfied and intrigued by for the longest time, ever since I can remember, whether it was just the very concept of the unknown that was out in space, or even just all the phenomena that it holds, such as dark matter, dark energy, or other phenomena such as neutron stars or black holes, or even hypothetical things such as wormholes or white holes. I really think just taking into account how much we know compared to how much we still need to know, and the very idea of just worlds and an entire universe out there that we still need to explore. I think that is also very satisfying for me. And neutron stars as part of space phenomena have also satisfied and not satisfied, but rather intrigued me and piqued my curiosity. And I think the idea of being able to study them with machine learning is also extremely well, especially even if the very idea of it is relatively recent in recent years. There's still so much we've done with it so far, which is what I want to go briefly go over here, and as well as slightly mention what else we can do with it and the other potential that we have for it. So, without further ado, I present to you a review of using machine learning to analyze gravitational waves from neutron stars. So here, let's go over just machine learning with neutron stars. So machine learning in general is just a form of AI or artificial intelligence that really just uses things such as algorithms to that we can analyze data with. Now, normally when we're using code or of any kind, we have to directly program our code to do things, even if it is analyzing data, especially if it is analyzing data. But with machine learning, we can just do that data analysis without having to directly program it, especially when such code would have to be done repeatedly and numerous times and over a long period of time as well. Now, with machine learning, we've been able to analyze data and study neutron stars and see recent developments in recent years. And neutron stars emit many kinds of data, whether it's light or radiation, or even in this case, gravitational waves. So scientists, as they collect this data and they can study things about neutron stars, such as their spin periods, like how fast they spin or their levels of energy. And the more they learn about neutron stars, the more they can understand and study them, which allows them to give, in general, a better understanding of the universe as a whole. And the most common forms of machine learning that are used with studying neutron stars are supervised learning and deep learning, especially with this. Supervised learning is where we take a model and using labeled data sets, we train that model, and then it can sort of predict and label other data or other data sets that it comes across. And with deep learning, the idea is that you train it is well, rather than training, you use a form of AI that trains a computer to analyze data, or you just really just think like a human being. So basically, you're just taking a computer and training it to think like an actual human being. And using this has helped us study neutron stars and understand them better. So gravitational waves. So neutron stars, as mentioned before, emit numerous kinds of data, and gravitational waves are among them. Gravitational waves in general are just ripples across space-time and gravity ripples, really. And these occur either when two neutron stars orbit each other and sort of circle around one another, or when a single neutron star spins and has what we call bumps or other sorts of imperfections. Because ideally, a neutron star has a perfect spherical shape, but if it does have such bumps or other imperfections as mentioned, it can also send gravitational waves. These gravitational waves as data and phenomena from neutron stars are more used with machine learning, more like with regards to using machine learning to study them, as they've shown more consistent and more promising in data. And been several different kinds of researches of machine learning in studying gravitational waves, whether it's from neutron stars, whether it's deep learning or supervised learning. So in the past, we've seen supervised as learning being used with gravitational waves and neutron stars. As mentioned, this is supervised learning is when we take a form of machine learning that uses already labeled data sets to train algorithms, and now that it's been trained, you can teach it to recognize and predict outcomes. And this has been used to study neutron stars through gravitational waves. One such study was a universal relations for rapidly rotating neutron stars, and this was using supervised as machine learning. And really, it was ending on gravitational waves, a study of neutron stars and specifically rapidly rotating ones. It also touched on something called universal relations, which, to briefly sum up, is just when a data set or a set in general, you take the elements inside them and you recognize, oh, okay, these two are related to each other. It's like if take space, a universal relation with space is that everything inside it is related by the fact that it's in space. So basically, it's just that the elements inside of a set are related to one another. And then there's of course another study over here where a model that was originally used to detect objects was eventually trained to detect binary neutron stars with gravitational waves, and it was successful in doing so. So this is another example of supervised learning. Another example, not well, rather examples of deep learning with gravitational waves from neutron stars. So deep learning is where it's a form of artificial intelligence, and this is when computers are trained to process or analyze data similar to how the human brain itself does. And this is also shown to be promising with studying neutron stars. Our first study over here utilized neural networks which detected gravitational waves, and this also will help detect and collect data on things such as binary neutron stars or black hole neutron star mergers. And well, with neural networks, they're basically just interconnected nodes or neurons of a deep learning system that are connected in the form of, well, a neural network, similar to what's in our own minds as human beings. And our second study over here, as shown on deep learning with powerful space tools such as LIGO or the Virgo interferometer collaborations, ends having detected black holes, or rather binary black holes, binary neutron stars, and even neutron star black holes with the use of gravitational waves. And this has also allowed scientists to better understand phenomena that neutron stars are emit. So, there has been promising research and data from neutron stars while using machine learning to study them. However, as mentioned, this was a recent development and it's happened over very recent years. So there's still much more potential and much more to be done with neutron stars and much more that can be done with them with regards to using machine learning to study them. There is the possibility that we can use different kinds of machine learning. As mentioned, we only used deep and supervised machine learning. Other kinds include such as unsupervised, linear regression, or clusters, and there's many several other ones. So those could also help, maybe not with collecting data, but rather organizing them. And additionally, other types of neutron star data can also be used, such as light or radiation or the spin rate of neutron stars. And other aspects could also include the lifespan or the power of a neutron star that could be predicted or studied with machine learning. And really, another concept could be just other different kinds of space phenomena that machine learning could be used to study, such as black holes, dark energy, or any other phenomena within the universe that just vastly remains unknown. that's all I have for this presentation. Thank you for listening. Thank you for your time. And thank you to the Polygence team, to my mentor, Maria, and to all of you.